part 2 of the semester final review. We're going to start at number 15. What did I tell you on Tuesday is the biggest thing you need to do on this final? What'd you say? Read the directions, okay? Because the directions or the problem tells you exactly what you're looking for and what you're working with. Okay, so Q, P, and ST are parallel. So what we are used to is we're used to extending these parallel lines. Okay, and then what are these lines called right here? Those are our transversals. So we're used to looking at these kind of extended. When you are looking at this problem, I want you to look for alternate interior angles. Go ahead and write that down. I want you to look for alternate interior angles. The reason for that is because what do we know about alternate interior angles and their measures? Are they the same or are they different? They're the same, so I want you to keep that in mind. Alternate interior angles should be the same value. So before we can answer the question, we have to know specific angle measures. Okay, it gives us one. So focusing on this little triangle here, what kind of triangle is that? It's an isosceles, okay? If I have two angles that are the same, two sides are the same, what else can I assume is the same? Those two bottom angles. Okay, so how can I work to find those?
180 minus 64 divided by 2.
Yep, take 180 minus 64 because that's going to give me what's left. That gives you 116. And then both of these here that are the same, those both add up to 116. So how do I find one of them? I'm going to divide that by 2. 116 divided by 2 is 58. That 58 gives me these two angles for that triangle. What else do I know about that triangle that I can fill in?
A vertical angle.
The vertical angle straight from here is also 58. Okay, now we're on to this big triangle. What do I know about this triangle? What kind of triangle is it? It's also isosceles. So do you agree that these should be the same? Okay, do you also agree I'm going to do the same exact thing I did the first time? Okay, so I'm going to take 180 minus 58 to get 122. What do I do with this 122? Yep, 122 divided by 2 is 61. That measure is for both of these angles. Okay. Now, once you have all the angles filled in, you should be able to answer the question. So, again, it asks, are these two lines parallel, why or why not? So this part A is saying no, because measure of angle P is not congruent to measure of angle T. That is true. However, do those two angles tell us if lines are parallel or not? No, there's no relationship between those two angles. Okay, so A is not our correct answer. B, it says measure of angle S does not equal measure of angle P, and measure of angle Q does not equal measure of angle T. Do those pairs of angles have relationship with each other? What is their relationship? They're alternate interior angles. So what should these two be? They should be the same. And with these two, those two should be the same. Are they? No. So B is our answer. They are not parallel because those are not the same angles. Their alternate interior angles do not match. So then you don't even need to go through C and D. Okay, so you want those alternate interior angles to match. So again, just make sure you're looking for these because you know those should be the same. Okay. Number 16 says, what value of x would support the conclusion that these two triangles are congruent by angle side? Okay. This theorem here means that they have an angle that's the same. They have two angles that are the same and a side that's the same. So what do I know about these two angles right here in order to satisfy that angle side? They have to be the same. Okay, so how do I set up an equation to solve for x if I know they have to be the same? Set them equal to each other. Okay, so I'm going to take 2x plus 18 equals 3x minus 47. And then we just solve the algebraic expression from there. So I'm going to subtract 2x. So I have 18 equals x minus 47. What's my last step here? Add 47. Yep. So I get x equals 65. Do I need to do anything else? Why not? That's all it asks for. Okay, so once you find what it asks for, you are done. Okay. Number 17 and 18 have to do with the same type of theorems here. So number 17, it's asking what theorem proves that these two triangles are congruent. So when we're dealing with two triangles like this, what are the only things we can assume?
If they cross and if it shows it, I guess.
Right, if it shows it, we can assume, okay, but we can also assume what they're connected by. Okay, what are these two triangles connected by?
The 90-degree angle.
This angle, right? What are these angles called? Vertical angles. So if this is 90, this side is
90.
also 90. Can I randomly assume that this angle is congruent to this angle?
No.
No. Can I randomly assume this side's congruent to this side? No. Only by what they're connected. So once you go that far, you want to pick one of your options. Which one should we check first? What's the reason for that? Right, if we have a right angle, we want to check if we have hypotenuse leg first. Does it have a congruent hypotenuse?
Yes.
Yes. Does it have a congruent leg? Yes. So hypotenuse leg is our answer. If you have these two specifically, does the order matter for those two theorems? What I mean by that is if I have a triangle here, does the order of the angle, side angle have to matter?
Yes.
Yes. Remember, you can't be jumping around the triangle. It has to be in that specific order. Okay? So a good example of that would be on number 18. Number 18, you have some overlapping triangles, but you want to focus on the two that they're talking about. So they're talking about UYZ and VYX. Now, if you want to bring highlighters or colored pencils or something to your final, you can. I will let you so you can highlight those because I know they're hard to see sometimes. But those are my two triangles. Again, what is the only thing I can assume other than what we're given? What they're connected by. So they're connected by this side here, so I can assume those two angles are congruent to each other. Can I assume anything else? I cannot. So now we match it to one of those 5 terms. Which one does it match? Side, angle, side. Yep, because it goes in the order of side, angle, side. Good. Moving on to number 19. 19, I changed it a little bit on you. EG says DE. Okay, so again, reading directions is key. First, it wants us to find what is DF. So DF is this length right here. In order to find DF, what do I need to find first? I need to find A. How can I find A? Why can we assume those are equal to each other? Okay, you can think that way. So he noticed there's a side angle, side triangles. You can notice that. But remember the term equidistant. If those two lines are equidistant, that means these two lines are also the same. Either way, both work. So how can I set up an equation to solve for A? Set them equal to each other. 3A equals A plus 6. So I'm going to subtract A. 2A equals 6. Last step. Divide by 2, so we get A equals 3. Is that my answer for DF? No. Make sure you're finishing the whole problem. What do I do with A?
Plug it into both of them and then add them.
Yeah, plug it into both. Do you agree if I plug it into both of these, I get 9? Yes. Okay, so it wants the whole length of DF. How do I find that? Add them together. 9 plus 9 is 18. So our DF equals 18. Okay. Next one it wants us to find is this side length here, DE. What information helps us?
They're congruent.
They're congruent. What else? Right. It tells us that right in here, the perimeter of our big triangle is 58. So what does perimeter mean? All the way around. Yep, it's all the sides added together. So if I know some of it's 18 and the whole thing's 58, how can I figure out the rest?
58 minus 18.
Yes, 58 minus 18 to give us 40. That means these two sides add up to give me 40. How can I find one of them if they're the same? Yes, take 40 divided by 2 to give you 20. So 20 is the length of DE. Okay, and then piggybacking off of that, number 20, they're talking about that middle line here, EG. Is EG a median? What is a median? Splits the side in half. Yep. So A is a median. Is it an angle bisector?
Yes.
Because
The angles are equal.
splits the angle in half. Now, on my key, I had these marked as yes. I'm not going to count you right or wrong if you have them marked. Okay? Because why did some of you not put altitude and perpendicular bisector?
Because we didn't know if it was.
You don't know if this is perpendicular or not, right? So I'm okay if you don't put those. But on this last one, is it a hypotenuse? No. Okay, remember, how do you know which one the hypotenuse is? It's the longest side and it's across from the 90-degree angle that would be there. Okay. Oh, I meant to cross that out, sorry. Not a hypotenuse. Okay. Okay, number 21. We should be very familiar with this because this is what we just got done doing. Okay, so 21, it's asking to list the sides from shortest to longest. How do I know what the lengths of the sides are without knowing anything about them?
It's the side across from the angle.
Right, the smallest angle, remember their relationship is across from each other. Do I have all the angles?
No.
No, how do I figure out the last one? Yes, I know 2, I can find the third. So I take 58 plus 63, which is 121. And then what do I do with 121? 180 minus 121 is 59. Now do I have enough information? Yes. What is my smallest angle?
58.
58. That angle is across from YZ. Do you agree that A is my only option?
Yes.
Yes. Okay. Jumping up to number 22. Directions say, what is the range? I had a lot of people ask me that question of what this means. Whenever you see the term range or possible answers, you're going to write this as an inequality. Okay, so whenever you see the term range or all possible solutions, you're going to write it as an inequality. Okay, what do I mean by inequality?
Greater than,
Less than, greater than, or equal to. Yep. On these problems, what did I always tell you to start with?
the algebra.
Start with the algebra. Do you agree 3x minus 6 is my algebra?
Yes.
Okay. 3x minus 6. Next, I want you to look at what you're comparing it to. Okay. Ask yourself, is 3x minus 6 our algebra? Is that an angle or a side? It's an angle, so do I want to compare it to another angle or a side? Another angle. What's my other angle? 24. Yep, so I have 3x minus 6 to 24. How do I figure out what the inequality is? It's based off of the sides that they're across from. Okay, so is 3x minus 6 less than or greater than 24? Less than because it's across from the shorter side. Okay. So once you have to set it up, once you have it set up, all you have to do is solve from here. Okay, so how do I solve this? Yep, add 6. So I have 3x is less than 30. Divide by 3, x is less than 10. So our range for x is all values that are less than 10. Okay. Number 23, you had a similar question to this on your test couple weeks ago. It tells us that KR, I'm going to make this my red line, KR is less than JS. Now, those are talking about sides, not angles. Okay, so KR is less than JS. These boxes here serve as your word bank. Okay, you can use them more than once. Okay, so we have two questions down here. The first one says measure of angle KJR, so that's this angle here. What is it compared to SRJ, which is here? How do we know the size of those? right, use this information. Okay, it said KR, which is here, is greater than SJ. So do you agree that this angle should be the biggest?
Yes.
Or sorry, the smallest. I read that wrong. Do you agree it should be the smallest? Okay, so KJR should be less than SRJ. Now let me give you a little trick. It should be the same as what it started with. Okay, the relationship should stay the same. Okay, because K, the angle K is related to side K. Okay, angle J is related to side J. Okay. Sorry, S. So it should match what the original statement said. The bottom one, let me erase my picture for a second. This bottom one is comparing the angle JKR, which is here, and RSJ, which is here. Okay, again, I'm going to base it off of its sides. So here's this angle. Do you agree the side across from it is this one? Okay, same thing with this one. Do you agree the side across from this angle is also this one? So what do we know about those two angles? They should be equal. Yep, since they share the same side, they have equal side lengths. Sorry, they have equal angle measures. Okay. What you could do at the beginning is if it says KR is less than JS, you can put in a fake value for that. So I'm just going to say KR is 50. What's a number that is greater than 50? Greater. 90, or I'm just going to do 100. So then you can see which angle specifically is the smallest if you want to base it off of numbers. Okay? 24 is kind of a true-false question. There's a table that asks you 4 questions and you have to pick yes or no. So going through the table, is x equal to 15? Do we know that right now? No. How do I figure that out? Right. When in doubt, what should you do with algebra on this test? Set them equal to each other. I feel like we do that on a lot of the problems. Okay, these two are equal because of that equidistant point. Okay, they meet at that point. So I can say 2x plus 7 equals 3x minus 8. We all comfortable solving algebra? So 7 equals x minus 8. Do we end up getting 15 for x? Yes. So x indeed is 15. Next question asked, does CQ, this line here, does CQ bisect angle ACB?
Yes.
Yes, because we already said they were equal to each other, right? Okay. Is CQ a perpendicular bisector of AB?
Yes.
Yes. Again, just like number 19, we can assume these two sides are the same, and we have that right angle this time. So yes is a perpendicular bisector. Is the measure of QCB, this angle right here, is that equal to 26? How do we figure that out? Plug in x. We're going to take x, plug it into here. So that turns into 3 times 15 minus 8. What's 3 times 15? Yep, 45 minus 8. Does that give us 26? No. So this one would be no. Skip 25 for now. I'll come back to it. We're moving on to number 26. It says a triangle has 2 sides with lengths 31 centimeters and 39 centimeters. What are the possible lengths of the third side? Again, when you see the term range or possible lengths, what are you going to write your answer as? Inequality. Okay. What helps people with this one is I always tell them draw a picture so you can visualize. What is the rule with triangles and their sides? How can you make a triangle?
The 2 smaller sides have to be bigger than theirs.
Right. 2 sides have to be bigger than the other side. So what is a true fact that I know has to be true?
X is greater than 8.
How'd you get that?
39 minus 8.
Right, because we know 31 plus x has to be greater than 39. Or a lot of you say, I'm going to take the difference or I'm going to subtract the 2 numbers. That'll get you the same thing. Okay, so here I subtract 31. So you get x is greater than 8. What is the other part we have to check?
Add them together. And then greater than X.
Yes, these two added together, so 31 plus 39 has to be greater than X. Okay, so what's 31 plus 39? 70 is greater than X. How do I write my answers once I have my two inequalities?
Oh, you put X in the middle.
Right, here's the trick if you get confused on how to write these. Your smallest number goes on the left, your biggest number goes on the right. What goes in the middle? X, and then what are these signs always going to be? They're always going to be less than. Yep, and if you check, X is greater than 8, true, and X is less than 70, true. Okay, so you want to write your answer on this one as a compound inequality. Number 27. I hope you like this question. If a figure is translated, what does it mean to be translated? Just moved, left, right, up, and down. If it's translated 5 units to the right and 3 units down, which translation will move the image back to its original position? How'd you get that? You just work backwards, right? So what's the opposite of 5 units right? 5 units left. What's the opposite of 3 units down? 3 units up. So your answer is B. Good. Okay, number 28. Do you remember way back when we did the symmetry activity? Okay, I feel like it's been a long time ago. But let's review. What does reflectional symmetry mean? It can be flipped, or like if you drew that line of symmetry and you fold it, it's the same on both sides. Okay, so I always tell people to think of a line of symmetry. What about rotational symmetry?
If you rotate it 90 degrees.
Right, what is the one stipulation with rotational?
It can't be larger than 360.
Right, it cannot be 360 degrees. Why can it not be 360 degrees? It would just be the same shape. That's cheating. Okay, that would mean every shape would have rotational symmetry, but that's not true. Okay, so 360 degrees does not count. So looking at this square here, number 1, does it have reflectional symmetry?
Yeah.
Yes, what that means is if I draw a line and I fold it over that line, is it going to be folded onto itself? Yes. What about rotational symmetry? Yes. Now I'm not asking degrees, but explain why does it have rotational symmetry? Right, if I turn it 180 degrees, is it still the same shape? If I turn it 90 degrees, is it still the same shape? Yes. Okay, so if you're struggling to see those, turn your paper. This next one, does it have reflectional symmetry?
No,
Why not?
because there's no line of symmetry.
Right, if I drew any line, is it going to fold on top of itself? No, because this side kind of ruins it. Does it have rotational symmetry? No. Again, do you agree this ruins it? Yes, so it does not have either of those. What about this squiggly line? Does it have reflectional symmetry? No. Does it have rotational symmetry? Yes. Can anyone tell me how much?
180.
180. Yep, if you flip it upside down, it's still that same shape. Last one, number 4. Does that trapezoid have reflectional symmetry? Yep. Does everyone agree if I draw this line, it'll fold on top of itself? Okay. What about rotational symmetry?
No.
It does not. So that's it. If it doesn't have one, just leave the box blank. Okay. Number 29. Again, we're talking about translations. What does it mean for a translation?
Just slide it and
Moving left, right, up, and down. I told you none of these were right? I made sure they're right on the test. Point P prime. What is P prime? Is that the old or the new? That's the new one. So that means P is old. Okay. What is the image of 5, -1 under the translation? 5, -1, is that my new or my old? That one's my old. We're trying to figure out its new image. Okay, so similar to, I don't remember what problem that was, from part 1, we're going to write our own rule. Okay, so what I tell people is drawing number lines. Okay, so I'm going to draw a number line here, put 0 in the middle. If I'm comparing my x values here, where did I start at? I started at 2. Where did I end up? -6. So how did I get from 2 to negative 6. Back 8, which means, you said it, minus 8. Yep, so I'm going to write my rule as x minus 8. Okay, now I'm going to do the same thing for my y values. What happened on the y values? Where did I start? Started at 3. Where did I end up? Negative 4. So 3 to negative 4, how did I get there? Y minus 7. So what do I do with this rule that I just made?
Apply it to the one that
To the new point, right? We're going to plug in this point. Remember, coordinates are always written in the terms of x, y. So my x value is 5 minus 8, yes, and then negative 1 minus 7. So now evaluate. You said 5 minus 8 is negative 3. What's negative 1 minus 7? Negative 8. So this is your new image. Okay, I really think those number lines help. Number 30, proofs. How do you always start proofs? With your given statements. When you're writing your given statements, what should you also do? Right. Mark them in your picture. So this one says BF is congruent to DF. And then your other one, EF is congruent to CF. Okay. What always comes after your givens? What they are shared by, what they overlap. What do they share?
Angle F.
It is angle F. Does everyone see that? Both triangles overlap at angle F. How do I write that in my proof?
Angle F is congruent to angle F.
Angle F is congruent to angle F.
Shared angle.
Reason is shared angle. Once you figure out what's shared, you should have enough information for what? What our next statement?
How they're congruent.
Right. Saying how the two triangles are congruent. So I have triangle BCF is congruent to triangle DEF. And again, if you struggle to see it, outline it. What is it?
Side angle side.
It is side angle side. Am I done?
No.
No. What should my fifth statement be, or my last statement?
Your proof.
Should always be that proof statement. Here's angle B congruent to angle D. What's the reasoning?
Corresponding parts.
Corresponding parts. Now, a lot of us put congruent or because of side angle side. I'm okay with that, just as long as you understand why they are congruent to each other. Okay, so if you don't specifically have corresponding parts, that's fine. Okay.
Wait, when will we get that?
Number 25, sorry. I forgot to label these, but I will have them labeled on the test. So we're finding the orthocenter. How many steps are there to the orthocenter? There's 3 steps, okay? So what is step 1? Finding the slopes. What formula are we using? The M equals, yes. Make sure Y's are on the top. What should you do right when you get your note card tomorrow?
Write this.
Write the orthocenter or
Yeah.
all of the stuff on the board. Write that down. Okay? How many slopes am I finding?
2.
2. Yep, I always try to stay consistent. I'm going to find AB and AC. Okay, so I'm going to find AB first. This is my x1, y1, x2, y2. So my y2 is 8 minus 0 over
2 minus 4.
2 minus negative 4. Those turn positive. 8 minus 0 is 8. 2 plus 4, 6. Now, a lot of us left it like this, which is fine, but you can reduce this to what?
4.
4 over 3. So now we do the same process for C. Here's my new x2, y2. So my y2 is 0. What's my x2?
0.
Sorry, y1 is 0. What is my x2?
8.
8 minus
4.
negative 4. So I get 0 over 12. Do you want to reduce this? Or like divide it out? Yes, you want to. 0 divided by 12 is 0. You should be happy when you get the slope of 0. And you'll see why in a second. It makes it a lot easier in the end. Am I done with step 1?
Yes.
Yes. Some of you do the perpendicular step in that step, which is fine. Step 2 is what?
Find the perpendicular one.
Right. What equation am I using in this one?
Opposite or circle.
That is for the perpendicular, yes, but the big equation I'm using is y equals mx plus b. So, I'm going to start with AB. I need my perpendicular slope. What is perpendicular to 4 over 3? Right, you want to switch the sign and flip the fraction. So I get negative 3 over 4. What coordinate am I using if I'm with AB?
C.
I'm going to use the one not involved, which is C, and C is 8, 0. Do I have enough information to use this?
Yes.
Yes, remember, this coordinate is always in terms of x, y. So what is my y value? 0 equals negative 3/4 times 8 plus b. Now, a lot of us are trying to multiply everything by 4 to get rid of this fraction. Okay, we have to multiply those two numbers together first. Okay, so think of this. How many times does 4 go into 8? 2. So then we're left with negative 3 times 2, which is negative 6. So what's my last step there? Add 6. So I get b equals 6. Don't brain fart here. What do I do next?
Plug it back in.
Write the equation. So I get y equals
Negative 3/4 x plus 6.
plus 6. Good. What do I do next?
Find out.
Same thing for AC. So AC, what's perpendicular slope to 0?
0.
It's going to stay 0. What coordinate am I going to use?
C. Or no, B.
Yep, I'm going to use the coordinate that's not involved. So B, which is 2, 8. And remember, that's in terms of x, y. So what is my y value? I'm going to start plugging it into here. 8 equals 0 times 2 plus b. Do you agree 0 times 2, that's just going to go away? Okay, so I get 8 equals b. So what's my equation?
Equals 0x plus 8.
Okay. Can I write this differently?
Yeah.
How?
Y plus 8.
Right, do I need this? No, because 0 times anything is just 0. So here we get y equals 8. Am I done with step 2?
Yes.
Yes. So the last step is to what? Set those two equations equal to each other to find your coordinate. So I'm going to take negative 3 over 4x plus 6 equal to 8. How do I solve this?
Times 4.
Now this is when you want to multiply by 4 because we don't like fractions. We want to get rid of them. Okay. Here, 4's cancel out. What am I left with?
Just
Negative 3x plus 6 times 4?
24.
24 equals
32.
32. Subtract 24. Negative 3x equals 8. Divide by negative 3. X equals negative 8 over 3. What do I normally do next?
Plug it back into either one of the top.
I usually plug it back in. Do I need to? Why not? Right, we already know what y is. So we know what y is. We know what x is. What's the last thing I have to do?
Make it a corner.
Make it a coordinate. So it turns into negative 8 over 3, comma 8. Now, I want to explain something. Did the 0 make it really nice?
Yes.
Okay? You get a 0 on your test. Okay, you get a slope of 0 on your test. So what should happen in your step 2 if you have a 0?
It should simplify down.
Right, you should get a specific y value. Okay, when that happens, okay, because you get lucky at that point, you may more than likely get a fraction here. I'm not saying you will, but I don't want you to freak out if you get a fraction because it is possible to get that with a 0 slope. Okay, does that make sense? Okay, do you guys have any questions over this orthocenter problem? Yes, ma'am.
Wait, can you explain, like, I get how you get negative 8 thirds, but
This here.
Yeah.
So when I'm writing my final answer, I want to write as an ordered pair. Ordered pairs are always in the term of x, y. So I'm just plugging in the x value into there. So our x value was -8/3. So I plugged it into there. And then I know y equals 8. So 8 comes into my y spot. And then that ordered pair gives us that. Good question. All right, any other questions? All right,